Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. We have got Auto Rescue Tools and Isaac Rodell as a sponsor for this podcast. Hey guys, if you're looking for programming laptops, you want the laptop set up ready to go for programming control modules on vehicles, you need key cutting equipment, you need diagnostic tools, Isaac is your guy. Has all that stuff available for purchase, and the support that he offers along with the purchase has been outstanding. I bought some stuff from him in the past. I got my Dolphin key cutting tool from him several years back. And again, the support has been phenomenal. Helped me out along the way with anything additional I needed to make it work for me. So make sure to check that out as well. Again, that's autorescuetools.com. The link will be in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's episode. Thank you for joining me. On the show today, I've got Andrew Rogue joining me. Andrew's a listener of the show. He's a technician down in Phoenix, Arizona, or the surface of the sun, as he's going to tell us about. And he's joining me today. He reached out on Facebook, and he recently went through a diagnostic on a Chevy Malibu that had a misfire. And he did come to the conclusion, but the testing results that he got kind of confused him, and he wasn't sure why he was seeing what he was seeing. Now, he's using a lab scope to try and assess a fuel injector that he thought was causing the misfire on this engine, and he got some results. And again, it was just something didn't add up, something didn't make sense based on what was actually the fix for the vehicle, what was physically wrong with it, and what he saw on the scope. And so he wanted to go through that with me and see if we could sort it out and figure out why he saw what he saw. And I said, sure, I'll give you, the best help that I can offer and see what we can do. And he sent me some notes and a scope pattern so we could look at it. And I'll probably post the scope pattern in the Facebook group so that you can see it too. And I think that would be really helpful. And maybe just pause the pod right here and take a look in the Facebook group. It'll be in the comment section for this episode, and you can see the scope pattern. It'll make more sense on what we are talking about. Now, a couple things I want to mention before we jump in here. First thing, this is a great example of lab scopes and how they can be really powerful. But the thing that's not talked about maybe enough is that they can also send you down some crazy rabbit holes. Things that you would see with a scope that you would never see with any other diagnostic tool. And you may think, well, that's the problem, obviously, right? I'm looking at this, I see this is an issue, but you would have never seen this particular, we'll call it a glitch, any other way. Well, that glitch may not be anything. It may not be a problem at all. It may be completely normal. It might be equipment failure. It's just the fact that when we get some of these scopes and we're not used to looking at particular waveforms, we don't always know what's normal, what's good, what's a problem, right? And the more you use a scope, of course, the idea is that you could pick that stuff out easier. But as we're learning these things, and not even just scopes, but just circuits in general, like you haven't connected up to this particular circuit on this particular car, so you don't know what's normal and what's a problem. And sometimes you can follow a thing that you think is the problem, but it's not the problem, right? And it's an important thing to remember about scopes, so we're going to talk about that. The other thing I wanted to mention, as I was editing this episode, I noticed something that I need to point out just for not only Andrew, and I did reach out to Andrew the other day, and after we recorded, and I talked to him about this, but I wanted to point out for everybody listening too, because it's important to know this. I didn't catch on to the line of thought while we were discussing this, but there's a point in the podcast, you'll hear it, where he mentions that voltage is low because amperage is high, and that can't happen, right? And we're discussing the potential of an injector that's drawing too much amperage that would cause low voltage. That's not a thing. That's not how electricity works. Go back to Ohm's law and the relationship there. In order to have adequate or even more than normal amperage, you have to have adequate voltage. If you don't, you're not going to have the amperage. That's it. That's the only way it works. So just keep that in mind as you're listening. We don't mention it during the show, but that is a thing that I'm sure many of you do know, but I wanted to make clear just so it's not something that was missed. Anyways, I really enjoyed this. Andrew's a very well-spoken, intelligent guy, and I'm glad he came on the show. I think everybody else will enjoy this as well. With that out of the way, let's jump in. So how's it going, Andrew?
Pretty good. The heat in Arizona is not something I'd wish upon anybody.
What part of Arizona are you in?
So I'm out in a little town called Buckeye, which is the westernmost suburb of the Phoenix metro area. So I'm right. Locals affectionately refer to it as the surface of the sun. It's been it has been miserable. Although today did cool down. We only I think got up to 108 today. So.
Jeez. Oh man. Yeah, I have some family that lives in Phoenix, and they've said the same thing, and they have a cabin. I'm not super familiar with the area, but it's way up in elevation as opposed to Phoenix. So it'll actually snow up there and stuff, which I didn't know that you could do that in Arizona, but they said they would go up there, now, and it's still like 90 degrees or whatever. And then, yeah, you guys are at 120 or like you say, the surface of the sun. So.
Yeah. You get a little farther north and it's a lot more bearable.
How much AC work do you guys do? Just like all day long?
We do a ton. It's frustrating from because I am a technician. I do work for a shop. I'm aspiring to someday own my own operation, and I'm not quite sure if I want to own a full-service shop or if I want to go kind of the route that you go of doing mobile diag and programming. I really enjoy the diag side, but we get a ton of AC work, and we'll have things like, your brakes are at, 1 or 2 millimeters of pad life left, and your AC is broken, and they only have money to fix one thing, and they're fixing the AC. You got belts showing on the tires, and we're not fixing the tires, we're fixing the AC. So it's like, people always prioritize that first, even over like safety concerns with a vehicle, which is frustrating from I care about like the big picture, which is maybe a fatal flaw. But yeah, we do a ton of AC work. Like it's mind-numbingly, it's annoying. Like I like doing diags. I don't like AC. I mean, it's like it's got a leak. Great. Like,
yeah, right. Yeah, sometimes you can throw in some electrical stuff there on the AC, or at least I get some of that doing the mobile thing. But it was the same thing when I was tech up here. Is come summertime, as soon as we hit that first 90-degree day, people will dump absurd amounts of money into their air conditioning system when, like you say, they've had this oil leak. Yeah, suspension's falling apart. You need brakes, you need tires. It's all rusted out up here. No, get that compressor running. And we get the people who maybe it's just like a hot summer, and so we go stretches a period of time in the winter where nobody uses the AC, and maybe it's a kind of a cool summer and they didn't really use it, and so that compressor or that AC system hasn't even been on in a year plus, and now they go to turn it on like, oh, it doesn't work, and they just come in, can you just recharge it? And maybe, but also maybe the compressor's locked up and the belt fell off and there's a hole in the condenser, and it's crazy stuff. But there was always good money in it, man. That was one thing about AC.
That is true. We've got a problem vehicle. It's in and out of the shop right now. It's a 2014 Ford Super Duty. And I think we've spent about $4,500 in AC. Like, we have replaced every component in the system, and without fail, it goes 2 days after it leaves our doors, and it stops working. And like, we had, like, this last time it left, I think it went a day before it stopped working. And like, it was done, and we had it in the shop, and we like let it sit there and run for 45 minutes. We had a couple different guys take it on like long road tests, like everything you could do to make sure it was fixed. And we gave it back to him, and the next day it stops working. So that's
stops working as in leaks out or something electrical.
Leaks
out.
Okay. Well, let me rephrase that. I don't know. I'm not working on it. Oh, and that's the I guess the frustrating thing, which kind of leads us into the reason that I wanted to come on here and talk to you, and that's doing advanced electrical diag is not something that really anybody else in my shop does. Like, I'm the only one that like, we have I've got a U scope, but then the only like real scope that I have besides the U scope is it's a Snap-on Triton little 2-channel scope, which is better than nothing, and it was really handy with this diag that I was working on. I guess this would have been yesterday, and so it's stuff like that is like, I don't know if it's an electrical issue with that AC concern, because it's like, we've done everything, and it keeps having this intermittent issue, and it almost feels electrical to me, but I'm not the shop foreman, and the shop foreman has been working on it, and he kind of has a bit of an ego, and he doesn't want to take that one down. And it's like, which is always frustrating in this industry when you get people with egos. Now, granted, I have a big ego, and I can be a bit of a prick, so it irritates me, and I do it.
There's a slight advantage to having an ego doing what we do. Like, you need to have confidence in yourself, and it can be a good thing, but yeah, you can go overboard with it, and it can be to your detriment pretty easily too. So there's just a balancing act there of figuring out what's the right amounts and when am I being a dickhead.
Exactly. And I miss that balance probably too often. I am the favorite tech in the shop. Everybody loves me. At least I like to think so.
Yeah, that's what we all think. Are you at an independent shop or dealership? Or
so I'm at an independent. I've been at independents my whole career. I work for a small independent right now. We've got I think we're running, we'll call it 4.5 techs, because I've got our foreman is kind of half in production as a tech and half just in management. And then we've got a 5th tech that's starting on Monday. So we'll see how he does. But yeah, we're a small independent shop, and we are also the shop that, like, we get all the problem cars from everybody else. So anytime a car's been through 2 or 3 or 4 different shops, it usually ends up coming to us, which is great. Sometimes it seems like we usually end up losing our shirt in one way or the other as far as making money on stuff, because we'll spend the hard part is charging for diag time when, like, the diag took forever, not because it was a hard diag, because of a tech's lack of experience. You know, like, if a tech floundered for 8 hours to conclude that a fuse was blown, it's like, is it really fair to charge the customer 8 hours when you should have checked the fuse first? And that's a whole nother.
I don't think so.
Yeah, that's a whole nother discussion. But Yeah. So I kind of want to move into this. I guess we'll call it a case study. It's kind of an ongoing case study since the car is still at my shop. This is a 2017 Chevy Malibu LS with a 1.5 turbocharged direct injected. I think it's a 4-cylinder. Yeah.
Okay.
So this car came into the shop initially. Let me see. I got it in front of me. Initially came in as a crank no start, and I didn't look at it initially. Another tech looked at it, and through the course of their diag, we found that the exhaust camshaft had actually broken in some fashion. I'm not sure if like the reluctor wheel on the back of the cam broke, or if the cam itself had an actual catastrophic failure. So, what did we do? Sorry, I'm looking through all the notes here and trying to make sure I get the storyline correct. So we found the broken cam, pulled the valve cover, found the broken cam, and so we replaced the broken cam, and then we did a full OE timing kit. So it got a vacuum, that's a gasket, all the chains and guides and tensioners and all that sort of stuff.
Mm-hmm.
And then they had a misfire. They had a misfire on, I think it was cylinder 3. They put a single fuel injector in cylinder 3. The misfire moved to cylinder 2. Then they put a full set of fuel injectors in it, and then it ran fine. The story that I got was it drove fine for 10 miles and then developed a dead miss on cylinder 4. And that's where I got it.
Okay.
So I guess kind of what I want to do, if you're good with this, is I'm just kind of going to run through kind of the process and what I did, and maybe just kind of run through it real quick, and then kind of talk about maybe where I could have done something differently, maybe if I misinterpret, because at the end of the day, the call that I made on this was wrong. And I'm trying to figure out for my own education, where did I go wrong in my process, and did I misinterpret a test result? Was there something I did wrong? So let me just run through this real quick. I know you've already read it, but for the benefit of everyone listening, I got into it. Had dead miss with flashing check engine light. I scanned the vehicle, all the relevant codes in the PCM. There were a bunch of coil circuits, injector control circuits, and a lot of previous testing had been done, some of which with the engine running. So I assume that most of these were set with just throughout the course of testing and weren't actually relevant to the issue. I think it was our misfire code. I looked over at the freeze frame data and found that fuel trim was indicated a super rich condition when it set that code.
So positive trims?
Yeah. So the freeze frame showed plus 17 on the short term and then 0 on the long term. And then when I looked at the data with it running, it was like plus 27, plus 25. So like way positive trims. Yeah, plus 26, and then long was plus 26, short was plus 33. So it had set this P0300 misfire code. I went and looked at the misfire counts, and cylinder 4 is a dead miss every cycle. Any RPM, it's dead, like dead. The cranking rhythm sounded okay. A quick, I guess, side note is the previous tech / shop foreman kind of got together, and they spent like 6 or 7 hours messing with this thing, and they concluded that we needed to remove the cylinder head and inspect for a valve actuation problem because they had a running compression test that was with erratic results, is what I was told. But like nobody wrote anything down, nobody made any actual notes, so it's kind of hearsay because this was like 3 weeks ago. But the cranking rhythm sounded normal, just like cranking on it. I removed cylinder 4 spark plug and found that it was wet, but not like soaked. Like it was wet, like we weren't getting spark is what it looked like. I tested spark coming out of the coil. There was good spark coming out of the coil, and I swapped it. I swapped the coil with the one next to it. So I swapped it with cylinder 3. So cylinder 3 is what we're doing a lot of swapping with because cylinder 3 is known good, cylinder 4 is unknown or known bad. So I swapped the coil with cylinder 3. Good, clean, bright spark out of both coils. Spark is not our issue. So my conclusion from that is spark is being sent to the spark plug, but for some reason we're not igniting the mixture in the cylinder. went ahead and did a static compression test, just cranking compression test. Cylinder 4 tested at 235 psi. Cylinder 3 tested at 245 psi. So, 10 pounds of difference in cranking compression between runs fine and dead miss every time. And then I went ahead and did a running compression test. Again, I don't have a pressure transducer to do this with the scope, so I'm just doing it with just a gauge. So I'm watching the needle bounce and kind of eyeballing for that fraction of a second when the needle hits the top number. Cylinder 3's peak compression was 120 to 130, so roughly half of what static was, which, if my recollection is correct, that's normal. And then cylinder 4 was the same thing, 120 to 130 is the peak. So the conclusion of that is there's no measurable difference in compression between cylinder 3 and cylinder 4. So known good versus known bad. Compression is the same. Compression is not our issue. So I got to break out my favorite tool in the shop. Well, my favorite tool is my pocket screwdriver, but I got to break out a lab scope for this one. I listened to your everyday carry of a Diagnostic episode today, and I was like, I'm the only guy in my shop that carries a pocket screwdriver in his pocket. And I use that thing all the time.
You've always got the solution right there.
Exactly. So the injectors have like a sub harness right on the top of the fuel rail, and there's a nice big connector, and you can get to all the pins to back probe it. I didn't have a good way to... I'm not opposed to piercing wires, especially down here, especially it's dry, we don't get salt. It's not... I don't have a problem piercing wires. In this case, back probing was just easier. So so these fuel injectors are controlled by the PCM. One side switches a ground, one side switches there's a discharge capacitor that spikes voltage up to like 65 volts to hold the injector open, and then it regulates at like 12, or 65 opens the injector, and then it regulates at about 12 to hold it open, and then it closes it. So I scoped number 3, which is just looking for a known good pattern. I actually, because it's a 2-channel scope, I hooked one channel into number 3, which is my known good, and then one channel into number 4, which is my unknown. And what I found was number 3's got a good clean scope trace. You can see the voltage ramp up to like 65 volts, and then you can see the pulse where it cycled it on and off, and you can see how long the injection pulse is. Everything looks great. Number 4 injector pattern, if you zoom way in, does the same thing, except the spike only goes up to 1 volt. So the injector takes 65 volts to open
1 volt?
1 volt. So the pattern was there. You could see the ramp, you could see the spikes, and they, using a trigger, I was able to see that they like lined up with each other. Just one only spiked up to 1 volt and one spiked to 65. But something was what I was able to conclude from that was that the PCM is not disabling this injector. Like it doesn't see a fault and it's turning it off, because I'm still seeing some amount of signal that tracks with what a normal signal looks like. So,
but the check engine light was flashing, right?
The check engine light was flashing initially. It was not at the time that I was testing this. It was on solid, and it just had the 300 code. It hadn't set the 304 for the cylinder 4 misfire yet.
Okay.
I checked the other 2 fuel injectors. Everybody's at 65 except for number 4 is low. There's a supply side and a control side, and the PCM switches both of them. And looking at a wire diagram on Mitchell showed the control side, or what the wire diagram showed as the control side, is where I was seeing the 65 volts, or seeing that spike to 65. Okay. I scoped the other side of it, which I think according to the diagram is the supply. I'm not sure exactly how this works as far as which way. I don't know how current flows, but there's 2 sides. I scope one side, I get 64. The other side, the pattern is at like you can see it moving, and there's a repeatable pattern, but it's like 1 or 2 volts. And I can check both number 3, which is known good, and number 4, which is known or unknown, or known, or that's our problem hole. And one side they look the same. The other side, one spikes to 65, one spikes to 1.
Okay.
I measured the resistance from that subharness down through the injectors. Cylinder 3, our known good, came in at 1.8 ohms, and cylinder 4, which is our unknown, came in at 1.7 ohms. So resistance wise, we're really close. At that point, I ruled out an injector. I pulled the PCM connector, and I load tested both legs, because this wire comes from the PCM. It's a one piece of wire. There's no connectors until the sub harness connector. I load tested both wires of the circuit, and then I also tested both for a short to power, or short to ground, and found no issues. Yeah, and there was some corrosion on another pin that was a sensor ground that I cleaned. I didn't think that was related to it, but I saw corrosion. I cleaned it. It's just kind of a thing, and that didn't. After I did that, nothing changed. So that corrosion wasn't causing our problem. I also checked resistance from the PCM down through the whole harness, and found resistance within 1/10 of an ohm of my test of the sub harness. So I checked everything, and based on all these tests, I recommend a replacement of the PCM, because everything else is there. I'm just not getting driver actuation out of the PCM. Put a PCM in it this morning and had the exact same symptom.
Okay. New or used? Just curious.
New from the dealer.
Okay.
So went back through, rechecked. I rechecked all the. I rescoped it, because at this point my boss is like, "Oh yeah, you called it wrong. It's in the head," and I'm like, "No, there's something wrong. There's something electrically wrong with this, because when I scope this wire, I've got 65 volts, and when I scope this one, I've got 1, and these should match." And so we kind of talked it through and concluded the only other thing on this circuit that could possibly be drawing it down is a fuel injector. So we ordered we got a new fuel injector, and then just didn't install it, just plugged it in to see if our spike would come back. And I had to clear the code, because we unplugged it with the key on, and it set a circuit code, and then it turned off that injector. But cleared the code with a new injector plugged in, started the vehicle up. You could feel the new injector clicking in your hand, and when I scope it, I've got 65 volts back at the injector subharness. So basically what had happened is somehow the injector, shorted is the word that comes to mind, but was drawing more current than it normally would, and was pulling that voltage down. But I guess what I'm trying to figure out is, how does that even work? Like, I can't understand in my head how that could be the case, and none of my testing would have given me any indication that was the...
So I was looking up diagrams and stuff while you were talking, just so I could get a feel for the setup. And there's a number of things that popped up in my head as you were going through that. Is there any other things that you wanted to point out on that before I jump in?
Do you want me to give you what I found when I put a new injector in it, or do we want to?
Let's hold off on that.
Okay.
Yeah. Okay.
Stay tuned.
So I know when I go after GDI stuff, when I first got my hands on a GDI car and I had a scope at the same time, I'm like, I'm going to scope the shit out of this thing. And I remember it was actually a Volkswagen. It was the very first one that I was able to hook a scope up to.
Oh, I'm sorry.
And look at, look at the injector waveform. And I'd done it like I did many, many other port injectors, where I'm looking at voltage. And I was very confused by how you could see control on both sides. And it made, where do I reference my scope in order to get a waveform that makes any sense to me, especially considering what I'm used to? Because again, like you say, they control on both sides. And something I'm thinking about on this one is they share a path for the boost capacitor in a lot of cases between a couple cylinders within the ECM. And so you'll see some activation from another injector on let's say I don't know if these ones do share in this application, and I don't know which ones if they do, but let's say 2 and 4 share a boost capacitor within the ECM. You could see activity from one on the other depending on which side of the circuit you're on. And so that makes it even more confusing. So what I do now when I'm trying to assess an injector operation on a GDI is I will go to amperage first and foremost. So I put an amp clamp around either one, doesn't matter. And that's the beauty of it. It doesn't matter. It's just which way I flip it. But then I'm looking at the amperage just for that specific injector. And I'm not so worried about the voltage unless, okay, the amperage points me that way. And now I want to see what's going on it. But I want to see the amperage, and it gives you, in my opinion, a clearer waveform of what the injector's doing, right? It's an output, it's doing work, it's drawing some current, right? It's only a couple ohms, so it's going to be really drawing some current, especially with the higher voltage, the boosted voltage. And so you can tell a lot by what's going on, and especially because you have, 3 other known goods right there, and you can go and compare. So that's the way I like to look at it, because that control on both sides and a potential shared path within the ECM between a couple cylinders can really make things difficult to digest on the voltage side of things with a scope. Not to say that if you really know that application and that car that you can't use it. For me, I find amperage easier to look at. Now that all being said, and obviously you'll get to what you end up finding, I'm just wondering if the ECM was actually shutting that down, and maybe you were seeing voltage or something
that was from a shared leg of the boost capacitor.
Yeah,
so,
and I'd have to look at the scope. Actually, I think you sent me the scope patterns. I should pull that up and see
a picture of it. Something that I struggled with that I think would have maybe helped to make this diag a little clearer is, like you were saying about a boost capacitor that is shared between one or more cylinders. Where would I go to find that information? Because I went digging through service information, I couldn't find any information as far as like what does the internal of this PCM circuitry look like, as far as how it's controlled.
See, and I pulled up. Oh, Identifix just booted me off. I pulled up the OE diagram because the redrawn definitely doesn't show you much of anything, what's going on inside of the control module. It just says, control high, control low. The OE diagram actually shows you basically a high, low side. I don't know if that's the diagram you were looking at, but it'll show a high and a low driver, but it's their generic GM symbols within the ECM. So on one side, you have the dot with the line through it, and then a switch below it, which is indicating that's power, that's GM's. Hey, we have power here. And then the other one's a switch to the symbol for ground. But the issue with that is if you're questioning it like you are, that's not actually what's going on inside of there. And the troubling part for so many technicians out there is, I want to know how they are actually connected within that ECM. How are the circuits actually driven? What's going on inside of there? And if you go way back to 90s wiring diagrams, there were manufacturers that would give you like that level of detail. They'd show a lot of the resistors and the circuitry inside of the PCM, and they kind of went away with that. For what reason, I don't know, but man, it would be really, really nice to see some of that detail, because I obviously this thing is not just powered on one side and ground on the other. I mean, even if they each have their own boost capacitor, that's in there, and it's not labeled in the diagram, so you don't even, necessarily know that it's there.
I just pulled it up just so I could see and track what you're talking about. Like, I had looked at the Identifix, the OE diagram, and that's how I was able to conclude, it's switched on both sides, because this diagram clearly shows that. But then it's like, you can't, the wire that switches the power doesn't tell you where that wire goes. It just disappears. And so,
yeah. The other thing I was going to look up here was the description operation, and maybe you already did that. I was curious to see if they outlined within there how the injection system is set up.
Yeah,
sometimes they'll give you little clues.
Yeah, so it says the ECM supplies a high voltage supply circuit and a high voltage control circuit for each fuel injector. The injector high voltage supply circuit and the high voltage control circuit are both controlled by the ECM. The ECM energizes each fuel injector by grounding the control circuit. The ECM controls each fuel injector with 65 volts. This is controlled by a boost capacitor in the ECM. During the 65 volt boost phase, the capacitor is discharged through an injector, allowing an injector electrical opening. The injector is held open with 12 volts. So that sounds like it's one boost capacitor, and then the ECM directs that to an injector. Like there's only one.
And that's, I suppose that's possible. Again, without actually going inside of the module, you don't know.
Yeah, like how do you... And obviously, I know you dabble a little bit in modules, and I don't. If the module's bad, I put a new box in it. That's the extent of my my module works. It's like I don't know, and that's, I don't know if there's really a fix other than trying to convince manufacturers to give us more information, which isn't going to do any good.
Right.
But yeah, like I feel like if I had a better idea of how this system works inside the ECM, if, for example, my conclusion was there's different boost capacitors, and the boost capacitor that runs cylinder 4 is bad. That's why we're still getting some actuation, but we're not getting the full amplitude as far as the voltage that we should be getting. But if, and reading through this again, it almost sounds like it's saying there's only one boost capacitor. But if I had a diagram that showed that, or if I knew there was only one boost capacitor, I could shoot down that theory, because if there's one boost capacitor and it works on this injector, then it should work on the other injector.
Right. The other thing I'm looking through here is sometimes you can find some information on the system, and this is particular to GM. GM is, I don't know if good is the term that I would use, but it's very common for GM to hide the system description or the detail about the systems within the definition of a trouble code. And they'll give you little bits of detail that is not found in their normal description operation. And so I'm just glancing through right now to see if there's anything that would and the other thing was that
I didn't have, there were no codes other than the misfire code or codes. It did eventually set a 304.
Yeah,
it was dead on 4, but there were no circuit codes for any fuel injectors or anything like that. And typically, and maybe I'm you talked about in an episode, like when I first started listening to this podcast, that sometimes like having some information is almost worse than having no information. And that, like,
yeah, no kidding,
just a little bit. And so in my head, I'm thinking if there's no injector circuit code, the PCM has run through all of its self tests and all the things that it monitors, and it's not seeing a problem on the circuit since I don't have a code. And the lack of code is not no information; it rules out certain things. And maybe that assumption was wrong. I don't know. I mean, I do know. I know now, but I don't. It's like today I know what the solution was. I know what fixed this problem, but I can't wrap my head around where my process went wrong, because it ended up kind of being like we shotgun an ECM that didn't work, kind of a thing. And I don't understand why. And that bothers me maybe more than it should, but like I want to understand what went wrong so that the next time I have a diag like this, I don't have the wrong call.
Well, I can say if, I had gotten to the point where you were at, one of the other things I would have done, and I can say this only because I've been in a similar situation. I had an Audi it was an injector problem. And it was shutting down the circuit to drive the injector. And this was a GDI. It was like a V6 or something. And it was intentionally shutting down the circuit. And boy, I don't recall the codes. I don't have that in front of me, but there were codes kind of pointing you in the right direction, or at least to that there was an issue with the injectors. But I powered up the injector by itself, right? So I took the computer out of the picture and I just sent normal battery voltage and ground to it, right? Obviously, they're supposed to get over the high pressure, they boost that voltage up, but you can still send power and ground to them as long as it's not one of the crystal stacks. That's a different animal. But for a regular copper winding injector on GDI, send 12 volts to it, measure the amperage, and again, you've got X amount of known goods on that vehicle to compare to and see. Yeah. And this one spiked the amperage. I wish I had my notes in front of me on this one. It was much higher than all of the other ones, is what I can say. Noticeably, I was just measuring amperage, connecting power and ground, and this thing was way high. And the computer recognized that, and so it just shut down the circuit. I'll let you go with what you found, and I'm going to see if I can find my notes on that Audi.
Yeah, while I'm sitting here looking through information on Mitchell, I'm looking through the OEM test flow chart for the fuel injector coil test, and I'm looking at what it calls for to test it. It says disconnect it, test for 1.3 to 1.44 ohms between the two pins, and if it's not within that, replace it. Now, my measurement when I checked this was not within that range, but the known good next to it was also not within that range.
Okay.
But yeah, I just found this. I didn't see this yesterday when I was looking at this. But even then, I don't know that would have changed the direction that I went as far as a call on that, because I've got a known good. This one works. This one works every time, and it works normally, and it's at 1.8. That is technically out of spec, but it works. And if the one next to it measures the same, you see where I'm going with that?
Yeah. And so temperature is definitely a factor, when you're looking at the resistance or something like that. And sure. I'll use a resistance value of something that does work, right? I try to evaluate components, electrically speaking, are they sending information or are they doing work? And I treat them a little differently, and I think about them differently when I'm testing, right? So an injector, obviously, it's doing work. It's drawing some current. And so not that I won't ohm check it, I will. And again, if they give you a spec, why wouldn't you? But I'm going to just kind of take that as one piece of information about it. And again, in a situation like that, I'm going to be sending power and ground to it to see, okay, let's force it to do work and see what happens, because, maybe once, because your ohm meter sending 3 volts through the thing and almost a minuscule amount of current, whereas this thing's meant to handle potentially 6, 7, 8 amps of current. Yeah. I just found my notes on this. And by the way, so you sent me a bunch of notes on this car. That's fantastic that you do that, because just for this reason, this was over a year ago that I looked at this Audi and I made myself some notes, but it's good that I can look back at this because I didn't remember any of these details. So This was an 07 Q7, 4.2 liter. I did have a code. It was a P2147 Group B injector circuit power supply circuit open shorted. That was the code. So that's a mouthful. Yeah, right. But and that's more a direction that I think you had with this one. But what I ended up finding is that there's 2 injectors that share, or multiple injectors share power feeds, but it's in groups of 2, and 7 and 4 are basically the ones that pertain to this code. Right. So you have to determine as a tech, is it 7 or is it 4?
Right.
And what the ECM would do is just quickly pulse the circuit, and then it would shut both of these down. So then you had to determine which one it is. And that part of it wasn't clear, that it was 7 and 4 and that either one could cause it. But I got there eventually. I do have a note in here. So for anybody working on one of these, the redrawn wiring diagrams are wrong. Imagine that. So use the factory if you're doing this one. But I did ohm the injector, and let's see, the good injector should be 2 ohms and 5 to 6 amps. I probably had a discharge battery there. And then the shorted one was 1 ohm and closer to 10 amps. And after replacing that one that drew 10 amps, that was only at 1 ohm, that fixed the problem. And then the computer didn't shut down the circuit anymore. So anyways, that was the one that came to mind.
I'm super familiar with that method of driving, because I specialize in like diesel, or light duty diesel. So I like pickup truck diesels is what I specialize in. So Duramaxes run the same way, where they group injectors together, and there's a super common problem. I think it's like the number 8 injector pigtail goes bad, but it sees that the ECM sees that problem and it shuts down the group, and so you lose 2 injectors. And if you're not familiar with it, you're going to chase your tail trying to figure out which injector it is. Like, that makes sense. There's information out there, you can find it, especially if you have a code that gives you a direction. This was like, there's no code that's dead. What's wrong with it? Figure it out.
Sure.
Which is fun. I like to be able to like stretch my diagnostic muscles a little bit, right, and get to do it, because I'm a line tech. I work on everything. So I mean, I'm doing cylinder heads on a 2006 Ford diesel right now. It's like I do big heavy work. I do a little bit of diag. So I like the good diag. So basically, we found that when we plugged the fuel injector in, our voltage came back, and so we went ahead and replaced it. And here, I'm actually just going to, real quick, so you can really appreciate this. If you pull your phone out, I'm going to send you 2 pictures right now. And
all right.
Our new tech is the one who put the injectors in. And when he installed the new fuel injectors, he did not remove the old fuel injector O-ring from the fuel rail. And what happened is, when he jammed the new injectors into it, the O-ring came apart, and there is O-ring debris down inside of the number 4 fuel injector.
Okay. So I can see that down in the middle there.
Yeah, there's like a little chunk of rubber down in there. So I can't really wrap my head around why that makes the injector not work. Another just side detail, I don't have an amp clamp that talks to a scope that can read that kind of low amperage. So that wasn't a test option available to me.
Sure.
But I wish it was, because I would really be curious to see, because if I don't know, like I really wish we could see what that amperage ramp looked like. Because I would assume that it's going to be drawing more current. But how does a physical clogging of the injector lead to it consuming more amperage? So much so that it draws the voltage down to a volt.
Well, I see. I'm still hung up on that the computer was shutting down the circuit to save the cat. And maybe I'm wrong there, but that's my good. If you just didn't explain any of this other stuff and just asked me, I'd be like, well, yeah, it probably just shut the circuit down. So, and again, maybe what you were seeing is voltage is residual or connected to another circuit. Again, we don't know the inner workings, and so the computer just shut it off because it saw a misfire. And once, well, okay, so
no, because when
you plugged in the new injector
It came back with the injector just sitting in my hand and plugged in. So now the circuit's doing what it should, and our voltage came back even though we still had the dead miss on 4.
Okay. Now I'm thinking through this. When I have that potential situation where I'm questioning whether an injector is shutting down a circuit, I will do a key cycle, right? And when you first start the engine, it should go back to pulsing that circuit. And that for a short period of time, and then once it determines that, hey, we have a misfire, then it's going to turn it back off. So I don't know in your scenario how the sequence on how it was tested, or if that could be a possibility. I don't know how long you let it run with the new injector plugged in and it running.
It ran for probably 2 or 3 minutes. I mean, it was more than a minute.
Okay.
So I would think if it was shutting it down because it saw a misfire, I would think that we probably were past that threshold where it would have seen a problem and shut it down.
So what I would be curious on is that injector that was full of O-ring stuff is just, like I say, operating that thing on the bench with 12 volts and see what it's doing. And now you could see it being physically restricted, but it's not like a motor, right? It's not when you slow down a motor, you're going to draw more amperage. This is very different. This is, electrically speaking, that injector hasn't changed at all, unless
and that's what I don't understand. Like, that's what I don't get. Like, I can see a problem. We put a new fuel injector in it. Our misfire on 4 went away, and now it works fine. I've got a misfire on cylinder 2. I did a cursory look through them. I didn't see any debris in any of them, but now I've got a misfire on another cylinder. So we've ordered up. We're going to swap out. We're going to do 3 more injectors and give it fresh injectors without the O-ring debris. But like, I can't wrap my head around how does a physical restriction in the inlet of a fuel injector cause an electrical issue like what I'm seeing.
Yeah, if my gut reaction to that is it can't, unless it were to physically damage the injector in a way which it damaged the windings, which I don't think is the case, because of, if that was to happen, your resistance value would be off.
And that's what I'm saying.
Then your ohm check is very valuable. Right.
So if I understand the way this injector works, and I haven't actually sliced one apart or seen what they look like inside, but there's a needle and a little, like a pintle at the bottom of it, and there's a needle that sits into a seat, and when it energizes that magnet, it pulls that needle back from the seat, fuel sprays into the cylinders, it lets go of the magnet, the needle closes. Like, there's nowhere in the body of this fuel injector where debris could come in contact with the electrical winding in the coil. So, and even if
I'm looking at a picture of one right now.
I guess I could have Googled that.
No, yeah, it's not showing you the inner workings of it, but I'm just looking at the body, and it looks like your very typical looking GDI style solenoid injector, where it is just a coil of wire around the movable, the pintle and the core, the solenoid. So like nothing.
There's no
nothing
moving,
special.
I should say there's no moving parts, because obviously something moves, so it injects fuel. But there's no, like, I work with the acronym is HEUI, hybrid electric unit injector, on older diesels, where there's like, you have high pressure oil that moves, and there's a solenoid that controls high pressure oil, and there's a piston that moves, and that pushes on, like, that has a bunch of moving pieces. This injector doesn't. There's one part that moves when it gets current sent to it. It pulls that piece back.
Yeah.
Fuel goes in. It lets it go. It closes it. So how does, and especially debris that is, it's an O-ring. It's not that hard, so it'll restrict flow, but it's not like you're dropping sand down it that could, damage some mechanical part of this injector.
But that's the thing, is even if one of these injectors, if you welded the tip of this thing shut, it will not change the amperage amount out of the injector. Right? It's not you do that to a fuel pump, different story, but an injector, that's not going to be the case.
Because the electrical doesn't care what the physical is doing. It's just an electrical winding, and when it gets current, it creates the magnetic field, and it pulls on whatever. Right? Like, that's all it does. It doesn't know, hey, there's restriction in the inlets or the supply side of this component. So
now, I'm just kind of thinking outside of the box here. Is there any possibility that you had the scope, like, maybe on the wrong scale when looking at that control circuit in reference to the other one? right? Like the volts per division, if they were on the wrong setting, it might show you, a lower voltage than, appears to be a lower voltage.
Sure. So I had it set up. I'm grounding my scale off battery ground, and then I ran my scale in. The Snap-on sets it up, and it gives you the way you select your scale is, it's like I put it in a 100-volt scale is 100 volts from the bottom of the screen to the top of the screen, or the bottom of your scale to the top of your scale. So I run it in 100. I can see the spike up to 65 on the one, and when I run the other one at the 100, you don't see it at all. There's just like some static in the bottom. But if I change that scale down to like 10 volts between top to bottom, then I can see I can zoom in on it and see that current ramp. Or it's not a current ramp, the voltage ramp. But
yeah, the voltage spike.
But so I know our wavelength was measured. Like I know when I overlay them together, I know I'm using the same scale, and I'm pretty sure we can actually see it in the picture that I sent you.
Yeah, let me pull up the picture that you sent me here.
It's all sideways. Oh, you can't quite. Oh, actually, no, you can. So the yellow trace, which is known good, and the green is known bad.
So you got that on a 50 volt.
Yeah, so you can see it goes up off the screen, and then the green's on a 10 volt, and it's barely moving at all.
So you do have them on different scales, but
yeah, just for the sake of this,
should be taller.
Exactly, the green should match, and obviously you can see on, I guess it's the bottom because this picture is sideways. I apologize. We're a little bit separated, so our yellow starts a little bit higher than the green, just for the sake of clarity of the picture. But yeah, we at this volt at a 10 volt scale, the green should be off the chart high. Like, I mean, you'd see it start to ramp up, and then it would just go off the screen because it's so much higher than 10 volts.
Are these, so what you're looking at here, this is the engine running, obviously, and two different cylinders?
Yes.
Is that correct?
Yeah, so yellow is cylinder 3, which is not misfiring. Green is cylinder 4, which is misfiring.
They shouldn't be happening at the exact same time. That's not how the engines work.
Yeah.
I think so for everybody listening, and I know this is audio only, we're looking at a scope pattern of two injectors right on top of each other, and they're right. The one in question is much lower voltage than the other, but they're perfectly aligned, which can't be the case for two different cylinders on a 4-cylinder.
You ever have one of those light bulb moments?
Well, I'm hoping I can help you out here.
I just had a light bulb because I saw something on the scope. So after we put the ECM in it and it still had a misfire, I hooked the scope back up, but I only hooked up one set of wires to it. So I had a yellow trace. I didn't have a green, or the green trace is not plugged into the scan tool. It's sitting or not plugged into the scope. It's sitting in a drawer. And I saw that same pattern on the green with nothing plugged into it. Like mid-morning.
Okay.
Which like just clicked in my head.
Sure. So it's got to be something picking up from
it's probably
the injector circuit up there.
Yeah, it's probably in the it's probably inside the scope. It's doing it. I'm not sure that's how or why.
That's potential, or it's picking it up like leads, laying on each other or something like that.
Yeah, but if I saw it this morning without the other one plugged into it.
Yeah, that's true. So yeah, it'd be in the scope. Or I'm just thinking maybe even on where is the scope grounded? Just on the battery, or
yeah, this is in this picture. The scope is grounded to the negative terminal on the battery, so I'm clipped right onto that.
Okay, all right.
Terminal.
So,
but that would
going
make
back
sense.
to this, then
that would make sense though if it's not if this test is faulty, because that's not actually what we're seeing.
Yeah, on the green, which it is when it was hooked up to the car, green was hooked up to cylinder 3, right? I'm sorry, it was 3 the misfiring one?
Or no, it's green was on cylinder 4.
Green was on 4.
Green was on 4, was their misfire, and then yellow was on 3.
There should be another event somewhere between the yellow pulses, right? So if you were to zoom out, you'll see multiple injector events on the yellow. There should be a green one somewhere in the middle between those.
Right, because you're not gonna inject fuel into both cylinders at the same time because they're not firing at the same time.
Right. And so if there was nothing there, again, it goes back to what I was thinking about, like it had shut the circuit down, or maybe you see it. Maybe it's there. The voltage is reading. Now, let me ask you this. Your trigger's set up on the yellow, isn't it?
Yes.
That's why. So you're always going to be focused in on the good cylinder because your trigger is showing you that front and center. And then whatever's happening on the green, you're going to see it, in the same time. And we're just picking up some residual voltage on that circuit. Again, maybe inside the scope, maybe something to do with the connection of the vehicle, but that would make sense. So my next test, if I had the car in front of me, is zoom the scope out and see what do I have going on in between the two yellow injector events.
Yeah. So that would track then. Like that makes sense to me, because if I went down a rabbit hole because I saw a low value as far as that, it didn't click in my head that what you're saying here, that these events are happening at the same time, and the same time in, I don't know if it'll show us. We're in milliseconds here, so the same time within a millisecond of each other, and it's all exactly the same. Two injectors are not going to fire at the same time. I can only trigger off of one. I can only trigger one trace at a time. Snap-on won't let me trigger off of two. So if this test is bad and the injector zoom out, off, well, yeah, I could zoom out and look at it, but if this test is bad and the problem is not that the PCM is not supplying, or the problem is not the PCM not supplying power to the circuit, or that the injector is drawing more current, it's that the PCM has turned off this injector because it sees a misfire, and we are getting a false test result because of some weirdness in our test equipment.
Yeah. Did you try having the trigger on the bad cylinder at any point?
I did. And it's the same. I had to move the trigger really low to catch it, but it was still catching the same pattern. But
so I bet you it was off then.
So yeah, I mean that makes the most sense. I mean that's not. I shouldn't say it makes the most sense. That's the only thing that does make sense, is if the PCM is turning it off because it sees the misfire, and for whatever reason 65 volts is enough that we're bringing up the voltage on our other trace.
Yeah. So this is a fantastic example of scope usage, and where it can be such a powerful tool that can separate you and tell you things that you would never know otherwise, but it can also
lead you down a rabbit hole.
Send you down rabbit holes that you would never have gone down otherwise. And I know a lot of people that use scopes on a regular basis are aware of that. But for somebody who is excited to buy their first Pico or their first U scope, you got to have that, in the back of your mind as often as possible, because otherwise, like, I've done this exact same sort of thing. I'll find a post on Facebook that I had. I was messing around with a 3.8, and I was picking up injector or ignition signals from another wire, and I spent hours on it, and it's something that I would have never done had I not had that scope. But it's like, well, it's right there. It's firing this coil twice, and
yeah.
Yeah.
So I get a little bit of a sidebar question, because you have a Pico, correct?
Yeah, I do.
Okay, so have you ever seen your Pico do something like this, where it's reading a voltage on a channel that you're not testing on? Like where you get so we're looking at channel 1, and I'm also getting it's bringing up channel 2 for some reason when channel 1 spikes. Have you ever seen the Pico do something like that? I mean, obviously, if you get a wire that's picking something up weird, but where it's strictly a failure. Yeah, where it's strictly a failure of the tool, where the tool is reading, your equipment's reading something that doesn't exist on a wire. I'm trying to talk my boss into spending money on a Pico because I don't have the cash for it right now.
Nothing comes to mind unless my setup is wrong. That's the scenario where I could say, yes, something like that has happened, but it's when I have something set up wrong, whether it be a ground lead not connected correctly, or I somehow have my leads touching and I'm not aware of it. But that's the only thing I can really think of. It's if you set up the test right, I think it does a pretty accurate job of telling you what's actually going on.
So I know you're going to have a some extent of an RF field around a voltage or a wire that's carrying a lot of voltage like this. Let's say you've got your two leads and you're doing this, like, you can't see it in this picture, but slightly outside of the frame of this picture, there's two piles of leads sitting there, because each lead's like 4 or 5 feet long, and the scope is sitting 4 inches from where I'm testing.
Yep.
I don't think that's the problem here, but could you potentially have an issue because your test leads are sitting right on top of each other? When we're talking about a voltage around 65 like this one.
Yes, and even more so when we're talking about ignition components that are 40,000. But the quality of the lead changes that or reduces that significantly. Okay. And so the Pico leads and a lot of other high quality leads, I can't speak to Snap-on. I've never owned a Snap-on scope, but I know the Pico leads are shielded in a way where you don't get rid of all of it. Right. Sure. And if you talk to really savvy scope users, they can tell, if they can look at a waveform on a car that they were not at, and they can tell you whether it was running or not, because they can see the interference from everything happening under the hood. And there's little bits of it, and you almost learn to ignore it, right? You just see the little blips in the voltage, and it's picking up stuff. And so you'll get a little bit, but the better the quality of your lead, the less you'll have that. Now, the opposite's true as well. If you're getting really cheap leads, which I've had, then you're getting all kinds of interference into those leads. So if you're going to invest, I mean, even if you don't have a Pico, but if you're going to invest in getting into a scope, don't go with the cheapest leads possible, because they're not going to be shielded to the same amount. And so you're going to get more interference from, electrically speaking or RF speaking. Under the hood is a very noisy place. And if you've got your leads laying over the top of coils and injectors and all this stuff, you're going to be getting some voltage induced into those leads.
Yeah. So I guess to kind of summarize what we've learned today, and the way that my brain is wired, I process things verbally. So like as I talk through a problem, I understand it better. To kind of summarize is where my testing procedure went wrong is I didn't notice that these spikes are exactly in sync with each other. I did notice, I took a picture of it, but it didn't click in my head that they shouldn't be in sync with each other, because we're testing two different cylinders. They shouldn't be synced together. And that's kind of where I guess kind of went down a rabbit trail, because I was looking at this data going, okay, there's a problem here. When if I had done maybe a little bit more testing, if I had unhooked the second lead and just used one lead and checked it, I would have seen that it was a flat line. There would have been nothing there.
Yep.
So,
well, you may have still seen that 1 volt. That's hard. You'd have to test and see.
I guess there's only, we won't really know. But so in my head I understand. So basically what happened, kind of backing up, fuel injector was replaced. The O-ring was left in the rail or in the line that goes to it. And so there was a piece of debris that went in, restricted fuel flow. ECM sees that as a misfire, disables the cylinder. We have it sees a misfire because there's a restriction in fuel supply to the injector, so it turns the injector off. But it doesn't set a circuit code; it sets a misfire code. And I had interpreted this test as it's still trying to fire the injector, when in fact this is a failure of the tool, and we're just getting bleed through voltage on the other scope trace from or between the channels. So the problem all along is not it's ramping to a volt, and that's a problem. The problem is that the injector is off because there's a misfire, which was caused by debris restricting the fuel injector.
Yeah, I can believe that.
Like, that makes sense in my head.
That drives. Yep, for sure. Yeah. Well, I'm glad we can make some progress on it. That's cool. I was like getting an answer, Sometimes you're left
that's why I was a little worried, because when I know we scheduled this really quick. I don't know if that's typical for you, but I was like, it's fresh in my head. I want to figure it out, but like I didn't have an answer yesterday, and I didn't have enough information to come to an answer yesterday, and so I'm happy to get to an answer today. So. Yeah, I think the moral of this story is, no matter how confident you are, remember that a scope is a really easy way to get down a rabbit hole. And that 2 injectors next to each other should not fire at the same time, which is like common sense. Like I know that. Like, it's not my first day on the job.
Yep. But we're not used to seeing it, electrically on a graph. I mean, some people are, obviously, but if you haven't, done that a ton, you're just looking for ejector patterns, and the two things don't come together. The only reason that stood out to me is because I've done like a ton of in-cylinder stuff and a ton of scoping, and so that came up in my brain. I was like, well, how come they're right on top of each other? Yeah, it's all experience, right? That's literally all it is, and that's
if you had an amp clamp, you would have caught this, because you would have seen current ramp on cylinder 3, which is working. You would have seen 0.
Would have never known about the 1 volt.
Yeah. That's what I guess I need to spend money on is an amp clamp, because that would have saved us from this whole rabbit hole. Yeah,
I absolutely love my amp clamp for sure. That's my go-to for so many different things. So, yep. That's the
moral of the story.
Moral of the story is everybody go buy an amp clamp.
And I guess this is where we segue into that ad spot for Jarhead. I'm sure he sells something. Also, just a side note while we're here talking, I was listening to an episode. You're talking about your everyday carry, and you referenced the amp clamp that is in your little bag. But you said everything in your bag was like less than $300, and my amp clamp was like $400, and I was just curious what amp clamp you had, or what your little one that read, I think, up to 100 amps is what you had.
Yeah, to be clear, this does not connect to a scope. This has a little
it's just a
LCD display on it. So it's a actually let me check the going price on Amazon here.
Because the amp clamp that I have is great. It'll read up to 600 amps, but it only reads down. It's it is only accurate to 1/10 of an amp. So I
$53 on Amazon right now for the Unity amp clamp. Yeah. Now, for this particular situation, running, it may not be fast enough to catch the amperage.
Yeah, but my head's off in a different world, and I'm thinking about parasitic draws now.
Okay.
That's why I want it, because I just need something that can read like fine amps without spending an arm and a leg, because I still work for a living and I'm not exactly made of money, as nice as that would be.
Yeah. No, I will say I use that thing all the time. Are there more precise ways to do draws? Can you use a scope? Yeah, that's fine. But I actually have two of those things. I have another one in the van, so I'll put them on multiple cables coming out of the battery, and then you can see it makes real quick work of not only is there a draw, but where's it going? Like which big cable off the battery, where's the draw going, and then I can at least find the fuse panel or the component that
and then work off
has the draw going. Yeah, but those things will go down to 50 milliamps. They'll drift if you let them sit for a while, but they're accurate enough for me to get what I need.
Yeah, and usually with a parasitic draw, you're not really, like if you're like 2 milliamps over, it's like you're usually it's not a 2 milliamp draw that's your problem. It's like you've got a module that's staying on a recorded wire and it's drawing a half an amp. Like, so usually that tiny little bit of accuracy in your diagnostic equipment is not super necessary. But yeah, okay. Sorry, total sidebar, and not at all related to what we're doing here, but yeah.
No, it's all good, man.
Do you want to maybe send me a link or put a link in the show notes to that amp?
Yeah.
Just that way I can have it, and then if anybody else who's listening is interested in that, then they can find it as well.
I will send the link to you right now, so don't forget. But yeah, I'll post that in the Facebook group too. So everybody should have one. Yeah, I guess so. You can crack these things open, and there is an EEPROM chip in them, I'm told. And you can change the functions of these things. And so when you first turn it on, and my employee learned this a few months ago when we made a bad call on one. When you first turn it on to any of its settings, the default is alternating current. And you have to press the blue button to get it to switch to DC, which is 99% of the measurements that I want to make is in, especially amperage. Not to say that you couldn't use it, but I want to measure DC amps, and so you have to press the button. If you don't know you have to press the button, you're on AC, and if it's not a changing voltage, well, amperage, it's zero, and so you don't think you have anything going on. So, but I guess you can go into this EEPROM and edit it. Google, there's a bunch of stuff on it. For me personally, I'll just hit the button.
So far above my pay grade, it's not even funny.
But yeah, there's stuff out there on it. So
if you have time and the passion for that sort of stuff, there's so many cool things you can do with electronics, and I have neither one of those two things. I like getting things right, and that was something that somebody asked you at some point. This was a while back. In the last 12 months, how many bad calls you'd had, or things that you'd called that were wrong, and at the time, I think your answer was 2 in the last 12 months, and you do Diag every day of the week. I mean, obviously you do programming too. And what I've shifted my mindset to is that with basically every problem on a car can be tested, and you can prove, generally speaking, you can prove a component failure, right? There is a test that can prove it, and maybe you don't have the equipment. In this case, I didn't have an amp clamp to prove the injector was off, but you can test to the point of finding your problem. And I guess that's the challenge that I run into is it's something you said in, I think, your last episode, was that you get, parts until it starts guys that are right 80% of the time. And it's like, they're a star tech because they get it right 80% of the time. And then, and that's kind of the shop that I work in. They're probably a little better than that, a little more diag than just shotgunning parts at it. But yeah, it's like pull the code, put the code on Identifix, what's the top fix? We'll try that first, and the problem is that 7 or 8 times out of 10 that works, and then I get the scope out and I'm doing this stuff and I'm like, and everybody's kind of looking at me like, what are you doing, dude? Like, what is this tool? I'm like, guys, it's a scope. This is cool. And then I go way down a rabbit hole.
Yeah.
Call a bad ECM, but it's not an ECM. So that worked out real well for me.
Yeah, it's a tough thing because, so you make that right call, 80% of the time, and you saved X amount of time from actually doing the diag. And so your productivity just looks awesome.
Yeah.
And those few that you can't figure out, whatever, I'll just push it down the road or whatever. But I think even within a shop, if, and it takes time, this is an easy thing, but you build that, that trust in people at the shop that they know they can go to you and you will get the correct answer. Now, maybe you'll get it wrong, right? And just for clarity for everyone listening, I've made a lot more than 2 bad calls in the last 12 months of my current life, but you will eventually get it right. There's a BMW, which I'm probably going to do an episode on, that I called a module on it and that didn't fix it, right? But I went back and I figured it out. And I think that's one of the important things to remember, especially when you're doing this stuff, especially when you're just, getting into the stuff like scope, is like, okay, yeah, you're gonna make a bad call here and there, but you stuck with it, you figured it out, right? And now next time you have one of these, here's the thing, next time you have something like this, like, you're gonna know the ins and outs of it so well that all of this stuff was, tremendously worth the time that you spent on it. And then, like I say, so over that time, you build the trust, people know that they can go to you, you're going to get the answer for them. And that's where the value comes from in all this stuff.
Yeah. Yeah. And that's the thing is, and that's kind of where I go, especially when it comes to some of these calls where it's like, I'm pretty sure, but I'm not 100% sure. And it's, what else could it be? What else is in this circuit? What else affects this component? What else could cause this issue? What if I'm wrong? What do I do next if I'm wrong? And in my head, I was going through this whole process in my head while I'm, explaining my service writer why we need a PCM. And it's like, and my head was, I was like, nope, that's it. It's PCM. Nothing else could be. I checked everything else. It's fine. Have a nice day. And clearly not. So I clearly have room to grow in my skill set.
Keep an ear out for the BMW episode, because like I said, I told them, yep, you need a DME. And by the way, I can clone it for you too. So I went through all of that, and then it was the exact same thing. And then I called my friends. Right, and that's the other thing, is having that network. I know I say it, people are probably sick of hearing me saying it, but I called Fonslow and I called Justin Morgan, and I went back today, and it's like boom, bam, I got it. Oh, how is how was I so far off? The first time around, but it happens, and this is the way it goes. So and I think I wouldn't feel too bad about it.
Yeah, I think the real secret, or the real trick to this is not beating yourself up over a bad call, and learning, going back and working through the process, like what we're doing here, going back through the process to see where did we go wrong, what can we do different next time so that we don't make the same mistake. And then like networking is a huge thing. I really need to meet more people that do like advanced diag, because I only knew one guy, and it was like an old boss, and we're on good terms. But what I learned is that my diag skill like passed his like 2 years ago, and so it's like there's not a lot of, Sean, you're the only guy I know, and I don't even really, I know you. I listen to your podcast, but like, there's nobody else that I know that I can talk through this problem with and go, what did I do wrong? Because I'm sure I didn't know that things like Vision and ASTE and all these things existed up until like 6 months ago, because I've been living under a rock.
Yeah, I mean, that's the majority of technicians out there, myself included. If I go back 10 years, I had no clue, no idea any of that existed out there, and the groups of people that are out there. So I'll send you some invites to some Facebook groups that you can get into, and that's a good place to start. Like, you can see, people talking about stuff. You can post stuff like, hey, what do you think of this injector waveform? And that's where it starts. And then you go to the events, you meet the people, and then that's when you really can. Exactly. You got a phone number to call, right? That's the thing.
That's the thing. It's like knowing who to call and knowing your guy. That it's just funny because like I'm that guy for so many techs that I know in the area, and even just in other areas that I've worked in. It's like I probably average like 2 or 3 phone calls a month. Hey, dude, I got this problem with a power stroke. I can't figure it out. It's like, it's great, but the problem is everybody's calling me. I have nobody else to call. So I need to spend some time building that network up myself. And
yep. Well, I was talking to somebody the other day who knew me from way back when. I've been fixing cars since I started as right out of high school or in high school, right? And I was telling him about what I'm doing now and all of the crazy smart people that I've met, and that I'm like a kindergartner when I'm in some of these groups, or I feel like that. And he's like you always fixed everything, blah blah blah. And I was like, no, you don't understand. Like, you think you're good at this stuff, and then you meet these other people that are like, holy shit, like they're in a different world. They're a different type of person. Their brain functions completely differently than me. And I just hope to glean a little bit of information off of them. It's like, you're the high school hockey star, right? And you're dominating, scoring 5 goals a night. Well, then you try to go play in the NHL and you're a 4th liner. That's like how I feel about it sometimes. But I do like it. Like, I want to be surrounded by as many people that are really smart and really good at this as possible. And like I said, just sort of
there's something to be said. If you're the smartest person in the room, you're in the wrong room.
Yes, I agree.
Surround yourself with people that are smarter than you, and it's going to make you smarter. And that's really the trick. And just in continuing education and always learning. And when guys get settled into a groove and they can turn out production, especially when they're flat rate and you're making money, it's really easy to just get stuck in that groove. But it's like, I don't want to be stuck in that groove. I want to understand what I'm doing, and I want to be the best at what I do. And I'm like, I would tell you that I'm pretty good at what I do, and then I listen to people like you and Fonslow and some of the other guys, and it's like I'm just like a little kid. Like, I don't know, am I even allowed to touch tools? Like,
you can hold the flashlight, okay?
yeah, exactly. So, anyways,
oh man. Well, thanks for sharing that with us. That I really enjoyed that. That was cool. So
I think we both. Well, I don't know if you learned anything. I learned something.
All right, that's going to do it for today's episode. Thank you, Andrew, for joining me. That was great. Hopefully, everybody listening enjoyed that as well and learned something from that. I thought that was really good to point out. This thing about lap scopes, where I use them all the time. I need them for my job, but you have to remember not to pick the fly shit out of the pepper, right? And that can happen. It happens to me all the time. So anyways, thank you again, Andrew. Thank you, everybody listening. But with that all out of the way, let's get out there, start fixing the world one car at a time.